Hello class, it's Mr. Wicklehouse again. This is the third video in this unit. This is the last video in this unit. Okay, this is a very short unit. That's why I put it in here before Thanksgiving, because I figured this would be a nice little short, quick thing to do before we went and ate a bunch of turkey and stuff. Alright. With that being said, let's get rolling. The fundamental counting principle. If event A can happen m ways and event B can happen n ways, they can happen together in m times n ways. For example, I'm making some cupcakes. And I get, I don't know what kind of cupcakes you like. Vanilla, chocolate, funfetti. So there's 3 kinds of cake, some frosting, some sprinkles, and I want to know how many combinations of cake can I make. Well, 3 kinds of cake, 5 kinds of frosting, 4 kinds of sprinkles. I just multiply those together and I get 60. Pretty easy. Here's another example. I have 6 shirts. I want to figure out how many ways I can hang them in my closet. Well, all I do is do 6, 5, 4, 3, 2, 1. Multiply all those together. The reason I do it that way is because to start off I have 6 shirts. Then I hang one up and I've got 5. I hang one up and I've got 4. Hang one up, I've got 3, and so on. So 6, 5, 4, 3, 2, 1 multiplied together. When you see something like that, you can write it like this with an exclamation point after it, and then that's called 6 factorial. It's called a factorial. These factorials get big really quick. For this particular example, multiply those all together, I get 720. Let's look at a different one, just to show you another example here. The 10 factorial. Well, 10 factorial is just 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You multiply all those together, you get 3,628,800. That's a lot of different ways to hang up 10 shirts. Alright. Here's another way to count. They're called permutations. You use permutations when you're choosing more than one thing at a time, and the order of it matters. Okay. To write these permutations, you'll see them written 3 different ways. This P this time means permutation, not probability, of N and R. So, the permutation of a number here, whatever it may happen to be, number of objects, and then R is the number of objects being chosen. So, like say 10 shirts, and I'm choosing 5 to wear on Monday, Tuesday, Wednesday, Thursday, Friday. I could do this by hand by plugging in n here as a factorial and then dividing it by n minus r factorial. But I can also use my calculator. That being said, let's look at the calculator here and figure out how to put that in. Let me try to get it back in focus here. There we go. Alright, so I go to math. I come over here where it says prob, and that stands for probability. I go to the NPR, which is the permutation. And let's just stick with the shirts. So I have 10 shirts, and I'm picking them for the 5 work days. They're Monday, Tuesday, Wednesday, Thursday, Friday. So I'm picking 5 different shirts. So how many combinations, or how many permutations is that? 30,240. Whew! That is a lot of possibilities. That's pretty easy to enter it into the calculator that way. And that's for these calculators that have it, that it shows up that way. Okay. Now here's another counting method called a combination. Again, you're using this when you're choosing more than one thing at a time. But unlike permutations where order did matter, combinations order doesn't matter. They're written exactly the same way as far as symbolically. If you're doing it by hand, though, you do n factorial over n minus r factorial times r factorial. Okay. Let's see how we do this in one of the more classic calculators, one of the older calculators that don't have quite as nice of functioning in them. I'm still going to go to math, but first, okay, I'm going to enter in my n value. Okay, so I'm going to do the 10 shirts again. This time I don't really care about, what day I wear a shirt, or like if I, pick it, if the order doesn't matter, in other words. So I put the 10 in, I go to math, go over to probability again, and this time I'm going to pick NCR. Then I'm still going to pick 5 different shirts, but you can see that's a much smaller number. Okay, but that's how I put it in the calculator. Alright. Let's look at a couple examples. Do this one first. Okay, a teacher wants to demonstrate how to collect data, I don't know where the date came from bouncing a ball. He randomly selects 3 students from his 20-student class. 1 will bounce the ball, 1 will hold the motion detector, and 1 will record the data, not the date, because that would be weird. How many ways can the roles be assigned? Okay. The order does matter here because he's picking 1 to bounce the ball first, then 1 to do the motion detector, then 1 to record. So he's doing a permutation of 26 students for the 3 different roles. You plug that into your calculator, like I showed you, and you end up getting 15,600. Okay. Now, we want to know how many ways can the roles be assigned, assuming you are selected to bounce the ball. So you're selected to bounce the ball. That means there's 25 students left and 2 more slots to fill. So I do 25, then my permutation, then I do the 2 because that's the 2 slots to fill, and I get 600. Okay. So this is, I'm being selected to bounce the ball. This is the number of total possible ways to be picked. So when I want to know what the probability is that I'll be selected to bounce the ball, well, assuming that I'm selected to bounce the ball, it's the 600. The total number of ways is 15,600. So I just put the 600 over 15,600, and that's equal to 1 over 26. It's not too bad. Okay, let's look at a different example. So there's a club. It consists of 3 girls and 5 boys, so 8 kids total. How many ways can a committee of 3 students be randomly selected from the club? Okay, so I'm just picking 3 students at random. I don't care what order they come in. I don't care who they are, whatever. Boy, girl, it doesn't matter. I'm just picking 3 students. So because of that, this is going to be a combination. Total number is 8. Number of slots I'm picking is 3. Plug it into my calculator. I get 56. Pretty easy. Alright. This says how many different committees of 2 girls and 1 boy are possible. For this one in particular, we have to think about the number of girls. We have to think about the number of boys. Okay. So I'm picking from the girls first. I don't care which girls are picked, so it's a combination. There's 3 girls, and I need to pick 2 of them. So the combination is, it's a combination of 3 and then 2. Now I bet you're sitting there thinking, where did that 5 come from? This 5 is because of a combination of the 5 boys, and I'm picking one. I don't care which one I pick. Anytime you have a combination of the total number and then you're just picking one, that's going to be equal to the number that you're picking. So there's 5 possibilities there. So that's where that 5 came from. This combination here is going to end up being 3, so I got 3 times 5, which is going to end up being 15. Why am I multiplying? Because I'm picking boys and girls. I'm picking girls and boys. So it's the probability of this happening and this happening. Okay, so now this is saying, the last question, what is the probability that the committee selected consists of 2 girls and 1 boy? Well, the total number that 3 students could be selected, the total number of ways is 56. Picking 2 girls and 1 boy, that combination is 15. So that probability is just 15 over 56. Easy peasy. Okay, last example. There's an urn containing 6 white balls and 5 red balls. A sample of 4 balls is selected at random from the urn. What is the probability 2 white balls and 2 red balls are selected? Okay. So what are the number of ways to select 2 white and 2 red? Well, there's 6 white, so that's a combination of 6 and 2. I'm picking 2 white and 2 red, so I'm multiplying. For the red, there's 5 red, so that's 5 and 2. Do the combinations, multiply them together in your calculator, you get 150. Now we look at the total number of ways to select any 4 balls. 6 white balls, 5 red balls, that's 11 total balls. I'm picking 4. Put that in as a combination. That's 330, so that's the total number of ways. This one is not a permutation this time, this is probability of selecting 2 white and 2 red balls. So I had to do this, then I had to do this to get the number of ways to get 2 white and 2 red, and then the total number, so 150 over 330, reduce that, I get 5 out of 11. That's all there is to it. And that's the end of our super fun probability unit. See you guys later.